This is the RSGC ACES program for grade 11, project 2.3, Ask Uno. The goal of this project is to input a simple command in the serial monitor of the Arduino coding system, to have it go through the nano and show up what was input on a liquid crystal display, which I couldn't find. Liquid crystal displays are also called LCDs. But then also to send it through the nano to the Uno, which actually does the calculation, and it appears here. So for example, 1 plus 1 is currently typed in. If I do 8 times 9, you'll see it will show up as 72, which is the proper answer when you do 8 times 9. Now, moving on to the code. To start off with, I'll discuss the code in the nano, or the host, as it's the one sending the code to the Uno. To start off, it imports the code from the Arduino Liquid Crystal Display library and the software serial library. Then I set up the pins that will connect the two, or in this case, the analog pins 0 and 1. Then I tell it how many rows and columns are in the liquid crystal display if it had one. Then, yet again, it reminds it that it's a software serial thing, so that way it can communicate for the chat between the Arduino Uno and the Arduino Nano. Then it sets up the pins that the LCD would be put in. Then it actually tells the Arduino which pins connect to which on the LCD. Then there's a set of code that is currently unnecessary, but would be useful if you had an LCD, as it would set up the LCD the same way that the serial monitor is set up on the computer. Then it tells the serial monitor to begin and the chat to begin, or the communication between the two, and it enters nano enter text. Then there's a loop, where every 3,000 milliseconds or 3 seconds, it will print waiting either on the Uno or on the serial display, as you can see here. Then it will reset the number of seconds it's been. But if anything is typed in, it will send those both to the serial display here and to the Arduino Uno to calculate. Here's the serial display. I could type anything I want in here and it will be connected to the other one. However, if I type in something that shouldn't be there, like exclamation mark plus exclamation mark, it won't have any positive effects for the code. It will just say does not compute. Now, moving over to the Arduino Uno. It yet again has a very similar beginning. However, it actually lets you change the baud of the display for both the chat and for the serial display, even though that isn't necessary. It does the same setup for the LCD, and it has a very similar setup as before, but now it has a timeout, so if the chat takes way too long to communicate the message, it will time out. Then it sets up a data string, or a string called data, so the code can be stored there, and a variable for the final calculation. Then, as soon as chat receives a message, it resets where the LCD cursor is, or where it will start typing from. It converts the message into a string, and takes only the first 3 digits, or operators of the string, and converts them into the variables n1, or number 1, s2, or symbol 2, and n2, or symbol 2. Then, while this may be confusing at first, it removes 0, but not the number 0, the letter 0, which may be confusing at first, but that's because it's not a regular number so far, it's a number on the ASCII table, which, as you can see, the number 1 is actually 49. So the numbers would be way off if you did it without removing the character 0. Then it double checks to make sure that both the first and third things inputted were digits. If not, it sets the operator to A, the character A. This is just a sneaky way to get around the switch statement, which is up next. The switch statement is a long line of if-else statements, where each case is its own if-else statement. So, for each case of plus, minus, times, divided by, or the remainder of, it will clear the screen and then get ready and set n3, or the result, to whatever the proper operation is. But if there's anything but an operator in the middle, it will clear the screen and say does not compute as a little computer moment. Then it will print out whatever's in there, or nothing if does not compute is there. And then finally, it waits 3 seconds, and then it resets N1 and N2. Now, on to the hardware. In order for the Arduino Uno and Arduino Nano to communicate with each other, they must have a chat system set up, as you saw back there. With this one, it's set up on analog pins 0 and 1, which are connected right over here. They also must have a common ground pin, which you can see is this big red wire here. But for this one, instead of having a separate 9-volt power source to power one of them while the other one's powered from a computer, I just connected their 5 volts, or their high pins, which you can see is this wire right here. That was Project 2.3, Ask Uno.